Network protocols are transparent agents that transfers data from your computer over the internet. It starts when you configure your computer to connect to your network. In this video, we will cover key network protocols that are commonly used. But that's not all. We will also cover common security protocols, so stay tuned till the end of this video. Let's start with your computer settings. Your basic network settings starts with IP, DNS, and NTP. IP or Internet Protocol enables identifying devices and routing data across networks to their destination. It assigns a unique IP address to each device, allowing them to communicate. IP addresses can be IPv4 or IPv6. A DNS server is one of the most important servers in the internet. DNS stands for Domain Name System. It serves as the internet's phone book, translating website names to IP addresses. Normally, when accessing a web page, your computer only knows the URL of the website. DNS servers provides its IP address to your computer. DNS uses TCP or UDP port 53. Synchronized time is critical for enterprise networks for security certificates, log correlation, and authentication. It's done using NTP or Network Time Protocol, wherein hosts are configured with same NTP server address to get the time from one source. NTP uses UDP port 123. Once you have configured your host, it will be connected to the network, and communication starts in the local network. Local networks have protocols to find other hosts in the network using ARP, or Address Resolution Protocol. It translates an IP address to a physical MAC address. It starts when your computer looks for the destination by asking the network for the MAC address of the known IP. In this example, who is 10.1.1.24? Need your MAC address. It sends it with a broadcast MAC address, then the switch floods the request to all ports. Since host C and host B does not use this IP, they will just discard the data. But host D will reply and the correct MAC address will be stored in your computer's ARP cache. So for the next transactions, your computer will send directly to host D. Another protocol present in the local network is DHCP, which stands for Dynamic Host Configuration Protocol. It automatically assigns IP address to devices when they join a network. It will provide IP address with subnet mask, default gateway, and DNS. It can also be configured to send the NTP server address. It starts when a client is connected in the network and broadcasts a discover message. The DHCP server receives it and offers an IP address to the client. Then the client sends a request to accept the IP address. The server acknowledges to confirm the assignment so that the client can use the IP. Discovery of adjacent devices also happens in the local network. Link Layer Discovery Protocol is an open standard protocol used to discover neighbor devices, and Cisco has their own version, which is the Cisco Discovery Protocol. Routing to other networks are managed through static routes or dynamic routing protocols. Dynamic routing protocols have two types. First are interior gateway protocols, which handles routing within your network. The most famous IGPs are OSPF and EIGRP. And to handle traffic outside your network, exterior gateway protocols are used. It routes traffic between different organizations in the internet, example of which is BGP. If you want to learn more about routing protocols, check out the link in the description. Transport protocols are responsible for the end-to-end segmentation and reassembly of data. Large chunks of data are broken and routed in the network. Then they are reassembled at the destination. For scenarios where order of data is important, TCP is used, which stands for Transmission Control Protocol. It establishes a connection using three-way handshake, which is composed of SYN, SYN-ACK, and ACK. Sequence number is inserted to every data in the stream to ensure that everything arrives in order. It requires acknowledgement for every segment that it gets. If the sender does not hear back before the retransmission timeout, it resends the data. It also has flow control mechanisms to avoid congestion. UDP or User Datagram Protocol, on the other hand, is a transport protocol for latency-sensitive applications. UDP does not guarantee delivery of data and does not have error correction because it prioritizes speed over reliability. It's commonly used for streaming, gaming, and video conferencing. TCP and UDP handles the transmission of data from one host to another, but there are also other protocols that work in your applications. Starting with FTP, File Transfer Protocol. It is used for transferring files between computers. like a file copy tool over the network. It uses TCP with port 21. It allows uploading and downloading of files between hosts. It has a secured version which is SFTP for Secure File Transfer Protocol. It wraps file transfers with encryption and uses TCP with port 22. SMTP or Simple Mail Transfer Protocol is used for sending emails. You use this when you hit send, and SMTP delivers your email to the recipient's mail server. The oldest port it uses is TCP port 25, but nowadays it also uses TCP ports 465, 587, and 2525 for security. HTTP or Hypertext Transfer Protocol is the language your browser uses to request web pages from a server. Server responds with status codes like 200 for OK, 404 not found, and 500 for internal server errors. HTTP has different methods like get, post, put, and delete to request for different operations in the server. HTTP uses TCP port 80. A secure version of HTTP is HTTPS, which stands for Hypertext Transfer Protocol Secure. It encrypts data using transport layer security to protect sensitive information. It uses SSL or TLS certificates to authenticate server identity. HTTPS uses TCP port 443. There are also protocols that are involved in monitoring and accessing devices in your network, like Simple Network Management Protocol or SNMP, which is the health monitoring system for your network devices. It collects information about device status, performance, and errors. SNMP has three core components, namely SNMP Manager, the monitoring server that collects data, SNMP Agent, software running on network devices, and MIB, Management Information Base, the database that defines what information can be collected. In a real-world scenario, SNMP Manager sends a request to the agent asking for info like CPU usage. Then the SNMP agent responds based on the available info on the MIB. Another protocol is Internet Control Message Protocol or ICMP. It is a protocol used by devices to send operational information. It is used to diagnose network issues and used by tools like ping and traceroute to check if a device is reachable and to measure latency. Remote access is important for monitoring and managing devices, so there is Telnet, which is a network protocol used for remote access. It provides unencrypted text-based communications with servers or network devices using TCP port 23. Monitoring and accessing your network is not enough. You need to be aware of the protocols that protect your data. There is SSH or Secure Shell, which provides remote access encryption. It creates a secure tunnel for remotely accessing and managing servers and network devices, like a private encrypted phone line to another computer. It uses TCP port 22. The network also have Radius and TACACS Plus for centralized authentication, authorization, and accounting. Radius stands for Remote Authentication Dial-In User Service. It operates on a client-server model wherein clients sends requests to Radius server for authentication. Radius is open standard, while TACACS Plus is Cisco's version of the protocol. In VPN connections, there is IPsec, which encrypts and authenticates entire IP packets. It's a suite of protocols to protect your data over the internet. It uses a combination of protocols, primarily authentication header for data integrity, encapsulating security payload for encryption, and internet key exchange for authentication and negotiating encryption to set up security associations between devices. That's it for essential network protocols. Like and subscribe for more networking videos. See you next time.